Okay, we are here in EcoMondo. It is a 3D exhibition about environmental technologies and solutions. And here, this year, we have more than 1,500 exhibitors from all sectors of environment. In particular, in the water area, the scientific program is initially addressing the European challenges. And we have discussed about different research programs that are funded by the European Union, Water JPI, Water4All, of course Horizon, the missions, and finally the results were discussed with stakeholders. The challenge here is still to find the right balance between the innovative solutions and the time to market. This was discussed in deep, and the follow-up will be a closer discussion, even in order to find an alignment between what is funded by public research agencies, by public programs, and what is the need of the market that here in EcoMondo is actually very well represented.
EBIBAN was a project that dealt with nature-based solutions and how you could use them to tackle issues with stormwater or with infiltration. We had participants from Norway, Finland, France and South Africa. And in the northern countries we worked with stormwater management, and in the southern countries in France and South Africa we worked with infiltration of water. One of the main outcomes of EBIBAN was two things. One were the detailed studies that were performed in the different cases. So, for example, there's a PhD from France and also from South Africa and Finland. And the other major output was the toolbox for adaptive water management. The results from EBIBAN are aimed to be used by researchers, water managers, and also people within governance and policy. However, the aim has been to make tools that can be used without being an expert in the field. So I would say it's indirect support to the policies through better management. We have placed the toolbox on the web, so it's openly available. With the project ending, also the funding ends, and this is always a challenge then for continuing. So what we try to do is link our results, the methods, up to new projects, whether they be for finance from the European Union or by stakeholders in the different countries. The best way to get something used, I think, is to get it used by the potential users. So we are working towards, for example, municipalities in Norway to have them start using it.
Our project, Mar Adentro, wants to enhance the natural power of the soil treatment, soil aquifer treatment through the addition of organic material and natural-based materials to degrade pollutants born with the secondary effluent of the wastewater treatment plant. And doing this with reactive barriers, we can enhance the levels of the water, but also to improve its chemical quality, but also the macrobiological quality. Yes, we are going to support the politics of the European Commission in order to find the correct way to improve the levels in the aquifers by the reuse of wastewater treatment plant, doing some kind and simple treatment with natural-based materials. During the development of this project, Mar Adentro, we also were funded with an European project. The LIFE project, in this case, is LIFE Remar, and we were funded to do another prototype similar to this one. So we are reproducing this one, but in another area of Spain also. But in this case, we are recharging a depleted aquifer that is used to extract water for agriculture, but it is also on the risk of saline entrance from the mar, because this is a coastal aquifer. And we have 1.5 years doing this new project, and now we are making all the basin and all the construction and so on, and we expect to start recharging in this aquifer in 1 month or 2.
Good morning. My project where we were involved is Blue Water Project, and participate for partners Università Politecnica delle Marche, Enea, MIBA, and the University of Uppsala, and it was related with the development of a new tool and new technologies to monitor, predict, and reduce the problem of the cyanobacteria and of the cyanotoxin in the drinking water reservoir. During the 4th year of the project, we were able to test and validate also in a full scale or with a demonstrative prototype the one technology, advanced technology, to reduce the impact of the treatment using a powered enhanced ultrafiltration system for the reduction of the cyanobacteria and of the cyanotoxic into the lakes used for drinking water production, and also several evaluation in terms of monitoring using drone and image system and tools or modeling for machine learning and predicted blooms were tested during the project. At the end of the project, we make dissemination of our results, especially with the water utility, where we validate the different solution. In the case of Italian case study, we started to think about an application of the approach also in the real full-scale plant. Are still ongoing some discussion with the companies on this, and also we're starting a plan for a more new advanced monitoring approach to be applied into the potabilization plant. Moreover, we think to test the new configuration in other projects to understand better the destination and the removal of other type of emerging compound, not only addressing the aspect of the cyanobacteria, cyanotoxic, but open also to other emerging compound into the water and also into the wastewater.